Number 5, this has 2 instructions. For each of the problems below, circle the answer to the question. Is the given value a solution to this equation? And then explain your reasoning in words. So there's a couple ways we could go about this. We could solve the equation and see what the solutions are. Or remember, a solution is just the value that if you substitute in will make the equation true. So if you substitute the 5 in for the x's, both sides should be equal if it's going to be a solution. Same thing here, put a 3 in. Same thing here, put a 0 in, where you see the x and see if it's true. So I'm going to do B, and then you do A and C. So I'm going to substitute 3 in for x, 3 minus 3 over 3 plus 3. And my question is, this is a question, right? Does that equal -1? So at this point, 3 minus 3 is 0 over 6. And does that equal -1? No, it doesn't. That's 0, and 0 does not equal -1. So is 3 a solution? No, absolutely not. It's not a solution. So my explanation in words, right? Explain your reasoning in words. When I substituted 3 into the equation for x, the left side was 0 and the right side was -1, which is not a true statement. So, and 3 does not make substituting 3 in does not make the equation true. So now do A and C yourself. I'm going to go ahead down here and do number 6 at the same time. So 6 has 2 parts. A, circle the equations below that have the same solutions. And then explain how you can tell that the above equations have the same solutions without actually solving the equations. So again, we could go through and we could try to solve each equation and see what the solutions are. But they're saying, how can you tell without actually solving the equations? So here's what we're going to do. We're going to look to see if any of these are just the same kind of equation but rearranged, or something done to the same thing on both sides. Like, for example, 7x minus 4 equals 15. If I were to subtract 7x from both sides, right? If I were to subtract 7x from both sides, I would have the equation -4 equals 15 minus 7x, right? And then notice that that's the same thing down here, just the -4 is over here and the 15 minus 7x is over here. So this equation and this equation will have the same solutions because they're basically just different versions of the same equation. They're equivalent, right? You can do something to this that makes it look like this and not break any of the rules. So you've preserved the equation. So these two are definitely have the same. Now, looking up here, what do we think about this one? Is there a way to have made this positive? Like, if we've got 15 minus 7x equals -4, is it possible that when I add 15 to 7x, that would equal +4? And no, there's no real obviously manipulation that I can do to this to make it that same equation. So this one is definitely not going to have the same solution as this one. Like taking 15 and adding 7x to get 4, it's not going to produce the same thing as taking 15, subtracting 7x, and getting -4. Let's look over at these two. Since we know these are the same, if you notice some structure, let's look at the structure. This structure, we've got a 7x minus 4 equals 15. In this structure, we've got an 8x minus 4 equals 15 plus x, right? So if you notice, this has some similar pieces of structure. The -4 and the -4 are the same. The 15 and the 15 are the same, right? The minus and the minus are the same. So there's some pretty similar structures, which mean we can just compare. If these things are all the same, then what if the only thing that's different is this has one more x on this side, and this has one more x on this side. And that actually keeps the balance, right? Remember, where equations are just things that need to be balanced. And if I add the same thing on both sides here, if I add an x on this side and I add an x on that side, I've preserved my equivalence, right? So this one is also equivalent. It's going to have the same solutions because I did the same thing to both sides. So now we can kind of go down, and now that we know this one looks the same, we can go down here and see if it's the same as this one. So let's think about this. If I take 15 and move it over here, I can't just make it positive. I'd have to subtract it. Same thing with the 4. I could take this one and I could add the 4 to this side and I could subtract the 15 from this side. That would be the same, right? Minus 15 plus 4, right? Add 4 to both sides, subtract 15 to both sides. But that absolutely means that this is not the same, because taking 8x's and subtracting 15, not the same stuff. So this is not going to necessarily give me the same solution. Here, again, notice we want to look for similar structures. Notice the 15 plus x is the same thing as the 15 plus x. It's this side that looks different. So let's see how this side matches up to that. Really, it's just a matter of factoring or distributive property, right? 4 times 2x and 4 times -1 actually gives me 8x minus 4. So again, this is just another way to write the same equation using algebraic properties. So here the difference is distributive property. Between these two, the difference is adding x to both sides, right? Between these two, the difference is subtracting 7x from both sides. So all 4 of these are equivalent. How can you tell that they're the same without actually solving the equations? We use things like adding something to both sides, subtracting something from both sides, factoring, distributive property. We use those things to compare. So you need to write that explanation in your own words.